Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at arrangements with both repeated objects and with restrictions. Let's start with repeated objects. So we'll go through that by looking at the question, how many different ordered arrangements are there of the word banana? So here we have repeated objects because we have 2 N's and 3 A's. We have some indistinguishable objects. Now, banana has 6 letters, so ordinarily the number of ways that we can arrange 6 objects in order is 6 factorial, which is 720. But here we have to account for the fact that there are repeated objects. So what we do is we divide by the numbers of those repeated objects. So there's 3 A's, so we divide by 3 factorial, and there are 2 N's, we divide by 2 factorial as well. So by dividing here, it stops us counting things like this. See, we could calculate this arrangement 3 factorial or 6 times because of these 3 A's here. If I treated them as different objects, there would be 6 arrangements like this that had these 3 objects in positions 2, 3, and 4. So that's why we need to do it, so that we are weeding out, we're making sure we don't double count the exact same arrangements, and similarly for the N's there. So we just take our number of arrangements like normal, but we take each of the objects that's repeated and we divide by the number of times it's repeated factorial. All right, let's now move on to arrangements with restrictions. So here we're going to answer the question, how many 4-digit numbers are odd and have 2 as the second digit? So here it's probably easiest if we use our boxes. So we have 4 digits for the numbers, and we're going to go and figure out how many possibilities we have for each of the digits. So for the first digit, there are 9 possibilities. You can't have 0 as the first digit of a 4-digit number, otherwise it's not a 4-digit number. So there's 9 possibilities. Now it says 2 is the second digit. There's only one possibility. It has to be 2. There's no restrictions on the third digit. So we could have any of the digits 0 to 9 inclusive. There's 10 in total. And because the number is odd, there are 5 choices, 1, 3, 5, 7, 9 for the last digit. So all we're going to do now is multiply these together. 9 times 1 times 10 times 5, and that gives 450. Of course, there are other ways to do this question, but I think the boxes is a good way to think about this. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.